Hey guys, how are you? So yeah, good evening ice cream and hello Evie of course. How about his further maths at A level? It's not that bad. It's not the worst thing in the world. Yeah, I mean, don't get me wrong, it's hard, but to be honest, you might like the challenge. It's mostly things like complex numbers and stuff like that, which isn't really too bad, and a bit more vector stuff. So honestly, I don't think it's too bad, in my humble opinion. Anyways, okay, so I think we can get started now. So what we're going to do today is I was requested to do some of those equation of a tangent questions. So I found some somewhat tricky ones. There's only a few of them. And then we'll go back to doing the kind of grade 9 paper that we were doing last time. Or we can go on to paper 2 or 3 if you'd like. So yeah, we'll go through some of that for now. So here's the circle centre O and the tangent to the circle at the point 4, 3 is on the circle. Find an equation for the tangent. Okay, cool. So it's probably the easiest one that we're going to do today. Because it's a good intro question. But essentially, the number one thing that you should remember for any equation of a tangent question is that the radius and the tangent are always going to meet at 90 degrees, okay? So that is the kind of number one thing to remember, and you're going to use it in every single tangent question. So, radius and tangent. And that's just one of your circle theorems. Yeah, you can use that kind of funky shortcut you did before. But we're just working out the tangent, so we don't actually need the equation of the circle in this question. So first of all, a tangent is a straight line. So what do we need for an equation of a straight line? Well, if I write out the general equation, we have mx plus c. So what we need the gradient. And then we need to work out plus c. So we can either work out the y-intercept, but we can't really see it on this diagram yet. Or we can try and just sub in a coordinate. So gradient plus one coordinate. Now the good news is that we actually already have a coordinate because it says it passes through the point 4, 3. So we've actually got on this bit. We just need to work out the gradient and we're done. So how can I work out the gradient? Well, as I said before, the radius and the tangent will always meet at 90 degrees, i.e. they are perpendicular. So if I work out the gradient of the radius and take the negative reciprocal, I then have the gradient of the tangent, okay? So, how do I work out the gradient of the radius? Well, it's always going to start at 0, 0 for GCSE, and it always ends up at 4 over 3, and you're just going to do change in y over change in x. So the gradient, so I'm going to call it m and then r for radius, not like molar mass or something, molar ratio. Change in y, so it's just 3 minus 0 over 4 minus 0. So in other words, it's 3/4. Now the cool thing with this is that essentially all you need to do, once you practiced it a bit, is you just divide these two numbers here, 3 and 4. Because again, the centre is always at 0. Trauma, yeah, exactly. Chemistry's fun, isn't it? So that means that my gradient for the tangent, which I'm going to call mt, is just the negative reciprocal. So I flip the fraction, so that's 4 over 3, and I change the sign, so I'll make it negative. Now I've got everything I need. So y is equal to negative 4 over 3 x plus c. And to work out plus c, I can use the coordinates 4 and 3. So when x equals 4, y equals 3. So using that information, I have 3 is equal to negative 4 over 3 times 4 plus c. So that's going to be 3 is equal to negative 16 over 3, sorry, plus c. So c is equal to 3 plus 16 over 3 by adding 16 over 3 to both sides. And what we need to do is make the denominators the same. So put that over 1 times the top and bottom by 3. So it's just 9 over 3 plus 16 over 3 which is just 25 over 3. I did that in a really long-winded way just to make sure that everyone was completely clear on how I got that. So of course you can do it much faster if you know how. But that is our equation for the tangent. And it's normally 4 or 5 marks, so in this case it happened to be 4, probably because it's the easiest it can possibly be. So I thought that's pretty nice, I hope. Okay. Are there any questions about that? So I think it was you, Ice Cream, that suggested this perhaps, I think. Is that kind of okay for the generic questions? Average acceleration? Okay. So when it says average speed or average acceleration, you're just taking the kind of overall speed or the overall distance and you divide it by time. On a curve, then what you're going to do is you'll take the difference in the starting and final velocities. So sorry, the starting and final velocity. The difference in that divided by time. So let's say you had like a curve. Velocity times time, and it went like this. But this, maybe it started off at, let's say it started off at 1, ended up at 9, and this was 3 seconds to make my life a bit easier. Then you do 9 minus 1 over 3. No questions, perfect. So the next one, if this looks a bit weird, it's actually because it's from the Welsh exam board, but again, they have to follow the same spec as we do, so it's all the same stuff. I thought this was quite an interesting question. It came out looking like trash for some reason. I'm not too sure why, but I apologise for that. So the diagram shows an arc of a circle, and it has an equation x squared plus y squared is 50. And 5p lies on the circle. That's a bit annoying. The arc meets the x-axis at Q. The tangent to the circle meets the x-axis at R. So a lot of information, but if we look at just the first value, it says find the value of P, which is the y-coordinate of P. I really wish they chose 2 different letters, but whatever. Well, if we have the x-coordinate, we can use it exactly like we would do a regular like equation, right? So if I say, okay, x is equal to 5 in this equation, we have 5 squared plus y squared equals 50. That's 25 plus y squared equals 50. Give me 2 seconds, Evie. I have seen out the corner of my eye you've messaged something, but I haven't read it yet. So yeah, y squared equals 25. So I did that a bit quickly, so I've just minus 25 from both sides. So y is equal to, technically speaking, plus or minus 5. Now, of course, it's going to equal plus 5 in this case. Right? So our GCSE papers that happened this year, any useful? Not particularly. You can kind of get a feel of the vibe, right? But you can't really get an indication of exactly what will come up. Yeah, not really. It's worth doing them though. So yeah, in this case, the P is just equal to 5. Yeah, but I mean, it's typical for physics, right? Yeah, it's worth doing it because at least then you can be prepared for a hard paper. And again, keep in mind, grade boundaries will be lower, so don't worry yourself too much. Part B, it says, show that the equation of the tangent to the circle at P is y equals mx plus 10, where m is a constant. So this is where we're actually working out the equation of a tangent. So, again, we use the same exact method. The radius is down here. Sorry, the centre's down there. So that's the radius. So if we find the gradient of the radius, which in this case is just going to be 5 minus 0 over 5 minus 0, which is just 1. We now know the gradient of the tangent, right? So the gradient of the radius is equal to 1. So the gradient of the tangent is going to be minus 1 over 1, so it's going to be minus 1. Okay. So we have y is equal to minus x plus c, because again, don't forget our normal equation is mx plus c. The coordinate we have is 5 and 5. So we can use that to work out what the equation of the tangent is, have I? Yeah, which would give you 10 in that case. The length QR was something that I thought was quite interesting because it gets a bit tricky. So again, the next part was just the same as the usual part. But for the equation QR, what you would do is you would work out, obviously, where the circle crosses the x-axis and where the line crosses the x-axis as well. Okay, so if we do that, assuming that's okay. So a few ways to do this. One of the ways is to, first of all, work out what Q would be. So how can we work out what Q is? Well, whenever it crosses the x-axis, that means y is going to equal 0, right? So y equals 0, which means you're going to have x squared plus 0 equals 50. So x squared is equal to 50. X is equal to plus or minus square root 50. So we can simplify that. We can make it root 25 root 2. So that's just going to be 5 root 2. And again, technically it's plus or minus. But if I look at what Q is on the positive x-axis, right? So I know that the actual coordinate there is the positive version. So 5 root 2 comma 0. Okay? And you can use the exact same method to work out what the the x-intercept is for r. So we worked out that the gradient for y was y is equal to, so minus x plus 10. So if I sub in y equals 0, we get 0 is equal to minus x plus 10. So that means x is just equal to 10. Which makes sense, right? Because it should be slightly bigger. Right, so 5 root 2 is less than 10, so that kind of makes sense on the diagram. Now, to work out the distance between 2 points, all you need to do, I mean, in this case, it's actually really, really easy, right? Because all we need to do is do 10 minus 5 root 2. But in normal cases, you'd have to find the difference between the x and the y, square them and add them together. But in this case, we can just subtract them. Does that make sense for that? So just subtract these two to find the distance between them. Just 10 minus 5 root 2. Perfect. And since it says exact distance, you can actually leave it like this, because don't forget, exact means you're leaving it as a surd, and this is indeed a surd. Okay. Well, a couple more questions on this, then we can go back to the grade 9 stuff. So I thought this was quite interesting as well. So the Welsh exam board has some interesting questions on it sometimes. But again, it's only 2 marks and 1 mark respectively. I'm going to zoom out slightly just so we can see the question and the diagram. So all the dimensions are in centimetres, that's good to know. And we have 2 circles, and they're both centred on O, because again, GCSE we tend to be. And the equation of the inner circle is x squared plus y squared is equal to 4. Okay? The equation of the outer circle is x squared plus y squared. It is 144. So work out the length of the line AB. Now, this actually isn't as bad as you might think. Remember, the number on the end is r squared, right? So the radius in this case would be 2 centimetres for this small one in here. And then for this circle, it's going to be the square root of 144, which is 12 centimetres. So if we square root both of those, we get the radius, or the radii. So the length of AB is just 12 minus 2. Because it's the difference in the radii. Yeah. So I hope that was okay. For the last part, it says write down the equation of the tangent to the outer circle. So again, a tangent, just so you're aware. Okay. Actually, I'm going to move it. I want to make slightly. There we are. So remember, with a tangent, it's a straight line that will touch the circle at only 1 point. Okay. Now, if you notice, it's a flat line, so the gradient is actually 0. Okay. So n would equal 0. And what would this coordinate be? Well, if this is 0 and this total length is 12, then it must cross at 0 minus 12. Okay. Now I did that pretty quickly. If it doesn't make sense, I can show you it using kind of a more mathematical way of looking at it. So using the actual equations. But if not, is that okay? Cool. Perfect. So my equation is just y is equal to minus 12, which is why it's a 1 mark question, by the way. Perfect. Don't think that's too bad. I believe we have 2 more questions if I'm not mistaken. This one I thought was pretty damn cool. So just so you know that this one is actually 4 marks if I remember correctly. And I'm pretty sure I do because there's 4 steps you're taking. And I think it looks pretty cool. And by the way, it is actually a calculator exam. Ignore that, I was using the calculator earlier. Yeah, so it is a calculator question. So we have a few points here. So we have B is 16, 0. It has an angle of 30 degrees. Point P is 3P and P. And we just need to work out what P is. Interesting. So if you remember, the one thing that I told you to always remember when you have tangents is that they're always perpendicular to the radii, or the radius of the circle. So what we can do here is we can actually work out what the length of O to A is. And the reason why I want to work that out is because it will give me the equation of the circle, right? So my thinking here is because point P is a point on the circle, if I know the equation of the circle, I can work it out. So that's my logic. But to work out an equation of a circle, you need 2 things. You need, technically speaking, you need the center of the circle, but the center is on the origin because it tells me here center origin. So that's good. And the next thing I need is the radius. The radius here is this length. So I can use trigonometry to work out what that length is. Okay? So, for trigonometry, this would be my hypotenuse, the length OB. This would be my opposite side, and this would be my adjacent side. So I have the hypotenuse. The hypotenuse is just 16. And I want the opposite, so I'm going to be using sine. So again, just SOHCAHTOA. Just writing this out for any of you that are slightly unsure. So again, the sides I'm interested in are O and H, so I'm going to be using sine. And the way sine works, it says sine of the angle is equal to opposite divided by the hypotenuse. So in this case, my angle is 30. My opposite is what I'm actually interested in. And my hypotenuse is 16. So 8, yep. So you could have done this part without a calculator actually, because you should know that sine 30 is a half, as Ice Cream just said. So 16 times a half, which is indeed 8. We don't need centimeters, we're just going to call it 8 for now. So my equation of the circle is x squared plus y squared is equal to 8 squared, which is 64. Cool. So what next? Well, I want to work out what P is, so I'm going to say at point P, x is equal to 3p and y is equal to p. So now it becomes just algebra. So we have 3p all squared. Again, a common error that I would see in this type of question is that pupils would write 3p squared. Don't forget, all of x is squared, so the 3 should be squared as well. Okay? So just remember that. Don't know why I didn't select the 3, but yeah. Plus, which is why whenever I substitute things, I always put it in brackets because I can make the mistake as well. So that'd be 9p squared. And again, remember in an exam, you're prone to making small errors. Okay, so that'd be 10p squared equals 64. So divide both sides by 10. We get p squared equals 6.4. And then you need to just square root it. And again, remember, this would technically be plus or minus, so we need to decide if it's going to be positive or negative. So there we are, square root 6.4. 2.53. Now the question is it positive or negative? Well, if I have a look, it's in the top right quadrant, which means both of these numbers have to be positive. So my actual value for P is 2.53, which kind of rhymed. Interesting. So 4 marks. I think it's a pretty interesting question. Definitely done it in a different way. But I'm going to scroll down a bit just so you can check the algebra. Anyone unsure? Yeah, it's pretty interesting. So again, my kind of top tip here. Oh, hey Lila, how are you? My kind of tip here, perfect, is whenever you sub things in an exam anyway, like if you're studying, okay, fine. In an exam, use brackets to substitute things in, because even I've made this mistake. Yeah, I'm very well, thank you. So recently I've been doing kind of complex numbers, and I've actually made this mistake a bunch of times, which was not fun. But I literally kind of, slightly different to this, but the same kind of thing, okay? You remind me of Mark. I'm sorry, but at least now you know how easy it is to make those mistakes, right? You can know exactly what you need to do and still get it wrong, sadly. Okay? But hopefully you have made the mistake in your mock, so you are aware of it. This is the last kind of equation of a tangent question we'll do. Then we'll go back to the paper we were doing last week. Unless anyone has any other topics they want me to go through or any other questions, that's obviously fine as well. So L is the circle with the equation x squared plus y squared is 4. I spent 2 hours on the question last night because I kept switching up the variable h and k because I couldn't read my writing. I've done that more than once, especially at university. Point P is a point on L, so find an equation of the tangent to L at the point P. So I would personally draw a diagram for this. Nothing special. I mean, not that any of my diagrams are special. You know what? I can make a perfect circle by cheating. Actually, I don't know if this is going to be perfect, but there you go. I drew a perfect circle. Okay. I don't think it's actually centered properly. Right. The center is 0. Okay. 0, 0. It's the origin. Let's just assume that I'm fine. And the point P is over here, and it's 3 over 2 root 7 over 2. And we have a tangent, so alright, that was there we are. Okay, it's a bit better to that point, okay? And we're trying to find an equation for the tangent. Again, we're doing the same type of thing. Find the gradient of the radius. The only difference here is that they do have ugly numbers, right? And this is a non-calculator question, by the way. So the gradient is just going to be technically it would be root 7 over 2 minus 0, so I'm not going to bother writing the 0, and then divided by 3 over 2. So if you were to write that out, you would get... Again, I'm doing this kind of slowly, so if you've done this in your head already, well done. But I just want to make sure everyone's on the same page. Fractions are just division, so you can write it like that. Remember, when you do a division, keep flip change, so it becomes times 2 over 3. So in my head, I knew that this 2 and this 2 would cancel out, but I understand that might not be obvious to you guys. But if you cross cancel, you do get root 7 over 3. Okay. So the gradient of the tangent, so I'm going to call that MT, just because I've done it all the other times, is you flip the fraction, so 3 over root 7, and you stick a minus in front. Bob's your uncle. Anyways, so we have an equation now. Y is equal to minus 3 over root 7. X. Why isn't it 2 root 7? Okay, so if you... Why isn't it 2 root 7? So I think I see what you mean. Like when you normally have like a fraction divided by another number, it kind of flips up and it would go up. That would only be the 3 that goes up, right? And it wouldn't go all the way up, obviously. So if you write it out, unless I've made a mistake, is that... No. If you were to write it out, you would get root 7 over 2 divided by 3 over 2. Why isn't it? So down here. Okay. If I write that line again, I did cross cancellation. So up to that, I think you're fine. If I do the multiplication now, I get root 7 times 2, which is 2 root 7, over 2 times 3, which is 6. If you simplify the fraction, you can divide the top and bottom by 2. Does that make a bit more sense? So I did cross cancellation. That's why I got rid of the 2 before. Yeah, that's fair enough. Maybe I shouldn't have skipped that step. I did cross cancellation, but yeah. Good. Okay, and lastly, all we need to do again, sub in the coordinate. So we have x is 3 over 2. So let's write that down. And we have y is equal to root 7 over 2. And I've got a feeling this is going to be an absolutely hideous number, but, you know, it's what it is. It's minus 3 over root 7. Yeah, this ain't gonna be fun, is it? Alright, let's do it. I don't think there's an easy way to do it, so let's just do some maths. Minus 3 times 3, so we get minus 9 over 2 root 7 plus c. Okay. We're actually going to have to... Great, okay, we get to make those denominators the same, that's fun. We have root 7 over 2 plus 9 over 2 root 7. You can rationalise it, yeah? You can rationalise the denominator, and that'll make it probably a bit easier. Oh my god. I think you got a bit too into it there. But yeah, so we can times the top and bottom by root 7 to make the denominators the same, which could work. Or we can times this one top and bottom by root 7 to make them the same. Either way is fine. What one do I want to do? What do I want to do? Please rationalise. Okay, fine. There you go. Thank you for making the decision for me. So we get root 7 over 2 plus. So that becomes 9 root 7. And the bottom, root 7 times root 7 makes 7. So we get 2 times 7, which is 14. Okay. So we're going to times the top and bottom of this fraction by 7. And we're going to get 7 root 7. Can you imagine if I got this wrong and it was actually a calculator paper? Oops. Is it though? So now we can add these. So that becomes 16 root 7 over 14. Simplify that a wee bit. We get 8 root 7 over 7. Yeah, okay, that's fine. So my equation is pretty damn ugly. Minus 3 root 7. 3 over root 7. Sorry, I misspoke. X plus 8 root 7 over 7. Good lord. That is the correct answer, by the way. Just FYI. Yikes. Pretty intense. But yeah, that's the last kind of equation of a tangent question. So, Ice Cream, are you okay with that? Does that help you a bit? Or is there any other questions you want me to do? I think you were the one that suggested it. Or does anyone else have any questions about equations of tangents? It's good. Perfect. Okay, I'm glad. Really, really glad. So what we can do then is we can go back to aiming for a grade 9. But in this case, you have the most easy but satisfying question ever. I mean, I'm interested in doing that as well. In the meantime, should we continue with paper 1, or would you guys like to see paper 2/3? I'll leave it to a vote again. I'm a fan of democracy. Look at this work we did. 2019 June has a good, easy, satisfying question. Which paper do you remember? Actually, do we really care about easy? I mean, come on, guys. Easy? We don't need easy. Calculator paper? Yeah, sure. Let's start with, okay, let's do paper 2 then, yeah? Good. So this is the aiming for a grade 9. Technically it's made by Edexcel, but if you remember what I said before, Edexcel and AQA are identical to each other, effectively. So don't worry too much about that. Okay. Okay. Well, this looks interesting. First question is an exponential curve. I mean, I don't think it's too bad. But if we have the equation of a curve is y equals a to the x. Also, feel free to let me know if you want me to kind of go towards the end. But we might as well go in order for now, at least. We can finish this next week too, by the way. So we don't have to finish this today. Because I know it's annoying sometimes when, people on YouTube only get through like halfway through a paper or something. Or in class as well, when you only get through the first half. We'll get through the whole thing, if not today, then at least tomorrow. Next week. So the equation of a curve is y equals a to the x. A is the point where the curve intersects the x-axis. So remember, that means x equals 0. So I'm going to fill that in already. So what's the coordinates of a? Well, then that means y is equal to a to the 0, which is just 1. So the answer to that is 0, 1. Pretty cool. The equation of the circle C is x squared plus y squared is 16. It's translated by the vector 3, 0 to give circle B. Draw a sketch of the circle B, label the coordinates, the center, and the intersection with the x-axis. Interesting. Okay. So what I want to do then, and I think this would be easier, is I want to work out where this curve intersects the x-axis first, because when I translate by vector 3, 0, this just means plus 3 to x. So if I work out all of the values on the normal one, I can then just add 3 to them. Okay, Evie, we'll do that question afterwards. I haven't read it, but we'll do that. So, to work out the x-axis, all we need to do is say that y equals 0. So x squared plus 0 equals 16. So x is equal to plus or minus 4, because remember, it should cross twice. Okay? So if you wanted to draw this graph out, the original looks like, well, it doesn't look like that, but you know what I mean. It crosses here. Now if I translate by vector 3, 0, I'm adding 3 to x. So what I have is a circle that's kind of off-center. And instead of minus 4, we will have minus 4 plus 3, which is minus 1. And instead of plus 4, we would have plus 4 plus 3, which is 7. Okay? And the center would be 3, 0. Any questions about that? Have a look through that while I read this question by Evie. 4 friends own books. Tiffany and Robert own the same amount. Oh God. What on earth? Why did it copy like this? Well, that's fantastic. I'm really glad that that's a button. Okay, no questions. Cool. So we'll try this question. Oh, I get it. Because it's black. Okay, there we are. There we are. Let's try this question then from Evie. So 4 friends own books. Tiffany and Robert own the same amount. Okay. John owns 4 fewer than Tiffany. Eva, God, that took a while for me to read that name, owns 5 times more than Robert. The mean number of books is 7, more than the modal number of the books own. What is the range of the books they own? Need to work out the range. Ah, okay. Yeah, I did miss that bit. Thank you. That means I get to do the same thing again. Oh, that one went. So why did that copy fine and the other one had this weird black background? Anyways. Okay. So wait, put it to a vote. Is everyone okay with doing this like question that Evie gave? I assume so. If not, I can kind of... that? Yeah? Alright. Let's go over to this then. Okay, perfect. Let's do it then. Now you get to see if I'm actually good at maths or if I'm just reading off a mark scheme, because I don't have a mark scheme for this one. So, okay, what I would do then is I'd say Tiffany, so T, has X books. Robert has X books. John has X minus 4 books. And Eva has fraudulent maths teacher, exactly, yeah. 5X books, okay. And the mean number of books is 7 more than the modal number, so that means the mean is just x plus 7, because the modal number of books is whatever, so I'll say Terry, Tiffany, and Robert has. Okay, so what's the range of books that they own? Okay, so the mean is x plus 7. Why is that relevant? Do I need to work out the number of books? Okay, so they gave me the mean for a reason. They must have given me the mean for a reason. So to work out the mean, how would I do that? What I would do is I would do x plus x, add up all of the pieces of data, divide it by the number we have, and apparently that should equal x plus 7. Do I need a hint? Do you have such little faith in me? Watch this be like a 1-mark question. I'm like completely overcomplicating it. So that's 8x. You're on the right track. Okay. I appreciate that. My anxiety was kicking in. Okay. So just by the way, I did this a bit quick because I'm actually really invested in this question. X plus x plus x plus 5x would be 8x, because there's 3 here and 5 here. Minus 4 will be there, over 4. So if I do this division, 8x divided by 4 is 2x. Minus 4 divided by 4 is minus 1, equals x plus 7. I'm going to move this x to this side, so minus x on both sides, and also plus 1. So I get x is equal to 8. Okay, so I'm pretty much done then, right? Because that means Tiffany owns 8. Robert owns 8. John, is it John? Yeah, John owns 4. And Eva owns 40. So the answer should be, for the range, 40 minus 4 is 36. Wait, what? What? I went wrong? Where? Wait, what? When? This? No, I didn't. Oh. So is my answer right? Did you hear the panic in my voice? Oh, okay. Did you hear the panic in my voice? Oh, no. Okay. So is this correct? Oh, okay. That is actually a really satisfying question. I actually tried coming up with a question like this, but the thing is, it's actually quite tricky to do, because you have to know the answer to be able to say about the mean being more than the modal and stuff. To be honest, I got a bit lazy with it, but yeah, this is actually a really nice question. Don't scare me like that. It's not fun. Okay. Oh, okay. I think that's a pretty satisfying one. Does anyone have any questions about this? So I assume Evie doesn't, but anyone else? That was a very fun question, actually. Thank you. I didn't say thank you, but yeah, that was actually a really good question. I like that. Yeah. All right, back to the regularly scheduled program. Again, feel free to find me another. All right. Feel free to let me know if you want me to skip to the end or like find harder questions. It was really good. Yeah, I actually quite enjoyed it. Bit of a puzzle. This is something that you have to do in science and maths, so it might be quite interesting for you to know or useful. So there's a speed time graph for a train, and it says work out an estimate for the distance the train travelled in the first 20 seconds. Use 4 strips of equal width, because hopefully you know that the area under a speed time graph gives you distance, so you're just working out the area. Is everyone okay with how to do this? Like, what's a good way to do it? So, yeah, you're okay with how to do it? Yeah? Triangles? That is one way to do it. I actually use trapeziums. But yes, so this is 4 strips of equal width. So we're going to do one every 5 seconds, right? So 1, 2, 3, 4. So what I mean by that is you have like a... Oh, for crying out loud. I really wish I could draw... So you have like... Just imagine they're trapeziums, please. The first one is a triangle, though. I'll give you that. And then you just work out the area. So we don't need to go through that. So do you want me to go through that, or is that okay? Good. Alright. So yeah, with trapeziums, you can skip. Perfect. Okay. And then over underestimate, it's... So if you look where I've drawn my lines, they're above the curve. So in this case, it would be an overestimate. So that's how you do it. Okay. 1 mark. Okay, I haven't actually read this. So at time t equals 0 hours, a tank is full of water. It leaks from it. There's 2% less water in the tank at the start of every hour. The volume is VT. Given that V0 is 2000, VT plus 1 is KT. Okay, so at this one, you're just working out the kind of percentage decrease. So 100% minus 2% would give me 98%. And then, because it's in a kind of iterative formula, I need to make that a decimal. Yeah, not too bad. Alright, you know what? Let's go right to the end. Okay. Circle theorem proofs. Interesting. Oh, I did not know this. Interesting. Sorry about that. I got really distracted. I found some really useful information at the end. I found the examiner reports for this. But yeah, let's go right to the end and let's have a look. This one might be a bit more... Has anyone ever done this proof before? Because if you have, it might be a bit easy. If not, this might be somewhat fun. Never? Aha! Yes! Good. So, you have... okay, fine. Well, at least now you're going to be testing your memory a bit. Do you use a compass? No. That's not a bad idea, but generally speaking, the diagrams... What they'll say on the front of your paper this year is all diagrams are not drawn to scale unless stated otherwise. So you cannot assume anything is drawn properly. The reason for that is a couple years back, they kind of made a mistake. They drew a diagram, but they didn't write that it... You know how in a lot of past papers it will say, diagram not drawn accurately or to scale? They forgot to put it on a question. And it was like a 5 mark and it said work out the length. And students measured it. And then they argued that because they didn't say that it's not drawn to scale, they can't have known, so they just measured it instead. And so now they've started doing it where on the front of the paper it will say all diagrams are not drawn to scale unless stated otherwise. So yeah, whenever you see these, they did get the marks, yeah, because they were technically right. Because, well, okay, their answer was wrong, but the fact that it didn't say they weren't to scale was not fair. So they got 4 marks. The question, I think either they got 4 marks or the question was discounted. Either way, it's the same thing. Okay. So, our goal here is to prove that this angle here is a right angle. Now, as you know from your circle theorems, if you make a triangle from either side of the diameter, it will always be 90 degrees. That's the circle theorem, which is why they said you must not use any circle theorems. So here's the proof, okay? To be honest, I don't know if you would have been able to know this off the top of your head. I didn't, so here's how you do it. First of all, if I draw a line from O to C, can we all agree that that is the radius of the triangle? And of the circle. And likewise, both of these sides are also the radius, right? Because A to B is the diameter. Because of that, both of these triangles are isosceles triangles, which means their base angles here and here are going to be the same. Now, I don't know what those angles are, so I'm going to call them Y, and I'm going to call them X. So my proof is going to try and show that x plus y equals 90 degrees. That's what I'm going to try and get to, right? That's not what I'm starting with. That's what I'm trying to get to. Okay. So, what can we do to work this out? Well, angles in a triangle overall should add up to 180. There we are. Lila's got it. So y plus x equals 180 degrees. So 2y plus 2x equals 180 degrees. And remember, this is what I'm trying to get to. If I factorize out a 2, and then divide both sides by 2, I indeed get x plus y, or y plus x, equals 90 degrees. 4 marks, I don't think that's too bad. So, by the way, this actually technically only gives you 3 of the 4 marks. Okay? What you need to do for the 4th mark is to say, therefore, ACB equals 90 degrees. Okay? Yeah, not too bad. Not easy, but not hard. Which was half complete, and I worked out the distance. She said in that time. Okay, I'm glad it makes sense, Ice Cream. So what I'm going to do is I'm going to show you the next question while I read what Evie is saying. So, in my mock, I had a speed time graph which was half complete. I worked out the distance you did in the time. What were you trying to work out, Evie? Speed. In the meantime, so we have another circle question. Shocker. Work out the sines of angle CAB. So CAB would be this angle here. And the first thing that I immediately see is that this is a radius and a tangent. So overall it should be 90 degrees. Yeah, so you took it away from the overall distance and divided it by the time remaining. Yeah, that would give you the speed that she ends up at. And for the... Yeah. That should have been fine. Yeah. Okay. So that's 90 degrees. Right? And it should also be noted that on the other side it's 90 degrees. So the way I would do this is... If you can get me the question, I'll show you. AOD is 180 minus 90 plus 32. Yeah. So this angle here, you would just do 180 minus 90 minus 32. So that's 180 minus 90 is 90, minus 32 would give me 58. Yes? Yes? 58 degrees? Yeah, email it to me, Evie, and that'll be fine. So then this angle here would be 180 minus 58, which is 122. Yeah. And then once again, we can just do the same thing again and work it out. Wait. Yes, exactly. So because both of these angles here are the same, all we need to do is do 180 minus 122. That would give me the sum of both of these angles, and then I'm just going to half it. So 180 minus 122 would be 58 again. So 58 over 2 is 29 degrees. Yes. So 90 minus 29 gives me the angle CAB, which is 61 degrees. Right. So again, I worked out that angle. Then I worked out this angle, which was 29. 90 minus that angle gave me this, which is 61, which is what they're asking for. Any questions about that? That's okay. Easy peasy. This question, by the way, we've already done it. It was literally the one that we just did. Wait. Did you say you weren't too sure, Lila? Oh no, you said no to any questions. My bad. Sorry. Yeah, forget it. I'm going to zoom out 1 second. Yeah, I'm sorry, I'm a bit slow today. Okay, so hopefully everyone can see this. Square ABCD is transformed by a combination transformation. So it's a reflection in the line x minus 1, and then a rotation. Under the combined transformation, two vertices are invariant. Describe fully one possible rotation. Okay, well the first thing I would do is I'll do the reflection. Now I will say that it is a bit tricky to teach you rotations over the internet. I think there is software I can use. I'm sure there must be. Someone must have it. But I would use tracing paper and then rotate it myself. Yeah, I'm sure there's something I can do to do it, but I haven't figured it out yet. When you're asked about an invariant point, is it the name or the coordinate? I would give both, to be honest. So, actually no, you can say the name. So you could say like point D and point B or something like that. But yeah. Okay, so reflection, all you do is, it was on your mock, perfect. Is you literally say how many squares is each part away from the line and go that many squares to the left. So I'm just going to do it, but please let me know if you're unsure of how to do reflections. Whoops. But triangles. Okay. Let's have a think. Okay. And remember, when you describe fully, you want... So in this case, we know it's a rotation. So you don't get a mark for rotation. You're going to get a mark for the angle plus the center. Now again, this is going to be quite tricky for me to do over the internet because I don't have tracing paper. But here's what I would do. Put the tracing paper on top of the whole thing, right? Make sure it covers the whole thing. Copy the actual square that we've just drawn. And then what you want to do is put your finger where the kind of center of rotation is, right? So maybe you want to start at 0, 0, maybe. And you just rotate the paper and see if you can get it to be on top of this square. Well, at least on top of 2 points, right? If you can't, then move the square around. How do you know where that is? Yeah, so what you want to do is you want to keep moving the actual center of rotation around until you get to it. There is a little bit of a trick I can show you. Yeah, with rotation it really helps if you have a good imagination. So for example, if I look at this point here, right? Here's what I would do. Okay, you know what? Screw it. This is what I would do. If I want at least 2 points to be invariant, right? I want to try and make this shape be on top of this shape. So what I do is I find the point that is midway between both squares, which can you see would be this point here. Can you see here? It would be that point. Draw right angles for 90 degrees. You can do that, yeah? You can do that. Tracing paper is easiest, or your imagination. But can you see that this point here is between these two lengths? Now, I would like to point out that I could also choose this point here. So why did I choose this? Well, if I look, these 2 points here are on the same line as these 2 points. So when I rotate it, they should end up in the same place, right? But either way, all you want to do is make sure that there's a line of points that you're equal to. So either one of those 2 points, can you see I can make that my center of rotation? Is that okay? Now, the reason why this trick works, so I'm going to say that the center is, so the center, and depending on which one you want to use, you can use -1 and 2, or remember, in an exam, you have to just pick one, but either one of those. There's a reason why I've done this, so I promise it'll make a bit more sense in a second. So you pick one of those 2 points, and the reason why I've picked those points is because if I rotate them 180 degrees, 2 of the points will be invariant. So it's a rotation of 180 degrees. So why do I pick 180 degrees? Well, one, it's quite easy to find the center of rotation if you're just flipping it, basically. And two, it's because you don't have to say... well, it depends on which one you're picking, which center. But it's either BC or AD. Right? So it's either one of those two. Like, it's either AB or it's DC, depending on which center you choose. But remember, the question isn't asking you which one it is. So you don't need to know. You don't need to write it out. I don't like rotating 90 degrees because it's a bit tricky to know where the center is for that. Okay. Some other ones that you could have had is you can also say anti-clockwise 90 degrees from this point here minus 1, 0, which would also work when you flip it around. Sorry, clockwise, not anti-clockwise. Is everyone kind of okay with that in general? It's a bit tricky. It's hard to describe over the internet, unfortunately. Maybe I'll do a video where I actually go through all of these, but I have to do it in real life. It might be worth doing. Okay, Ice Cream says yes. It is tricky. I'm not going to lie to you. Okay. Get the camera thing seated. Yeah, I mean, to be fair, I do actually have like a proper camera. And if you go on my YouTube channel, you can find some pretty bad videos early on where I did them in real life. I need to learn how to use the camera properly to make the quality better. But like, I do have that facility. You know? It's just a pain in the neck to set up. Professional cameras suck. They're really tricky to use. It's probably why people go to university and college to work out how to use them though. So, yeah. Okay. This next question we did, like I said, in the earlier part of the lesson. So again, we did equations of circles and tangents and stuff. Well, equations of tangents to circles. Yeah. Were they actually? Were they actually though? I don't know about that. Yeah, you know what? I'm actually happy with every video I've put out. I'm not gonna lie. Like it's not bad at all. I'm trying to find a question we might be able to do right now because we don't have much time left, and unfortunately, I do have to leave a bit more on time than I usually do. Yeah, these are some really good questions, by the way. Like this is a 5-mark bearings question. Yeah, we're gonna do a 5-mark bearings question. But we could leave the rest of this for next week. Oh God, what is this? Oh wait, I've done this. I did a question very similar to this. What's my email? Yeah. Whoopsies. That's my email. Yeah, I did a question very similar to this. Oh, this is going to be fun to do if we do this next week. Yeah, we'll do this next week. I messed up a cosine question, which was 5 marks because I did the wrong bearing, but knew how to do the actual... That is really frustrating. That's so frustrating. It happens a lot more than you'd think, which I don't know if that makes you feel better or not. But yeah. By the time of your exam, hopefully, I mean, you're going to be under more pressure, so you're going to be more focused, so hopefully you won't make the same mistakes, which is a very good, I mean, obviously it's a good thing. But make mistakes now because you don't want to make them later. I also realised I wasn't recording this, so that's going to be fun to do the edited version of this. Yeah, bearings are fun. But I think if we can leave it here... I apologise for leaving kind of on time, I guess. I know that you guys tend to have more questions, but next week I'll definitely be able to... We'll finish off this paper, and maybe even paper 1 too. And thank you for love. Live. Yeah, you're very welcome. I'm more than happy to do it. But yeah, feel free to email me questions and then I'll go through them in the lesson. So I put my email in the chat. So if during the week you find a question you want to do, email me and I'll either email you an answer or we'll go through it in the live stream. So if you just say like live stream for live stream questions or can I have an answer now, I'll do both of those. But that's my email address if you ever need any help with any of that. But yeah. Yeah, I'll email you a solution. Yeah, 100%. So I'll email you one, but if you specifically want it in the live stream, then we'll do it in the live stream. Yeah, so Evie, your question will be done by email. Hopefully, by tomorrow. Yeah. No problem. Yeah, you're very welcome, Ice Cream, Lila, and Evie. Thank you for joining and participating. It's good fun. But other than that, I'll leave you to your evening, and I'll see you next week. Next week should be your last week before Easter, so that's fun. You too, Ice Cream, you too. Yeah, one more week till Easter. Then we get 2 weeks off to get some good work done. And maybe we'll do like a special like revision stream type thing. Who knows? But yeah. Enjoy your week and I'll see you next week.